Picture class, let's look at how we raise powers of complex numbers in polar form, 2 powers. So we have a polar form of a number. So this is r. These are our values for theta. Right, remember that puts us into the complex plane. R is 4, so we're on this circle of radius 4 in the complex plane. And then the 2 pi over 9 would be some really small acute angle like that. Let's just say hypothetically that's our complex point. So when we cube this, when we raise it to a power, what happens is we get this elongation of the value r. It's going to be cubed, so it's going to be much longer than it was. Like 2 cubed is 8. 4 cubed is 64. It gets much, much longer, but we also rotate. So this gets, instead of cubed, the whole number is being cubed, but these arguments, these angles, get multiplied by this number. So the angle is 3 times what it was before. So that's that angle 3 times. So 1, like 2, and then maybe 3, something like that. So we get, a longer value for r, but also rotated. So now we may be here, way up here in this part where it's a different color. Let's do it in this color so we can see it there instead of where we were. So we get longer and we rotate, and we get a new complex number from that procedure. All right, just like we would if it was real numbers. You cube a real number, you get a number that's much further away. It's also real, so there's no rotation involved. So how do we do it mathematically? Well, we cube r, we cube the 4, and we multiply the angles times that value, that power. So instead of it being 2 pi over 9, it's 2 pi over 9 times 3. That's our new argument. And plus I times the sine, 2 pi over 9 times 3. So there's our new polar coordinate. 4 cubed is 64, and then the 3 goes into the 9 3 times in both of these cases. So we have a 64 cosine of 2 pi over 3 plus I times the sine, 2 pi over 3. So that's the new number in polar form. Okay, but look at what it's asking us to do. Give it to us in rectangular form and then exponential form. Exponential form is much easier. The exponential is just the value of r that we have right now, and then e to the I times that 2 pi over 3. So that's the exponential form. The rectangular form, I'm going to need to distribute the 64 through there and evaluate the cosine and sine of 2 pi over 3. So that's where my unit circle will help. So there's my 2 pi over 3. The cosine is -1/2. The sine is square root of 3 over 2. So when I'm multiplying 64 times these two, the 64 gets multiplied by the -1/2 to give me a -32, and then plus I, and then the sine of the 2 pi over 3 is the square root of 3 over 2. So 64 will get divided in half by the 2 and give me a 32, but it'll be 32 square root of 3. So there is my rectangular version of that number. All right, so there is my rectangular form. There is my exponential form. So just make sure that you understand where things go and what you do on a problem like this. The 3 is the 4 is raised to that power, but these angles are multiplied by that power when we come up with the new polar form. Switching from polar to exponential is straightforward. You just take your new value of r, take your new argument, and you plug it into that form right there, the r e to the I theta. But the rectangular form, the x and y, you're going to need to use the unit circle to help you make those conversions.